Oh, I need to go into Meet Echo, or they can see this via video, huh? Yeah, that's okay. Yeah, appreciate it. We have this device, which should work. I hope. At last time it worked. Oh, sorry. Why is this weird? Sorry, very weird. Why would my PF go? Yes. Let's go. Yeah. So, blue sheets. Yeah, okay, let's fill out the top later. May I take that pen again? Okay, full screen. If I manage to do that. Oh, wait, F5, I think, is the solution. Let's see. I'm sorry, and I'm not. Oh, God. Just take it for these things. The clicker is doing something, but it's not doing what I'm expecting it to do. God, I'm so sorry. Yes, we just go.
Good morning and welcome to DOTS. My name is Roman Dinidu and my co-chair Tobias Gundam. Next slide, please. So you've seen it before, but just wanted to reiterate that the note well is in place. Next slide. So we have the blue sheets getting passed out, and wanted to thank Chris Morrow for being the Jabber scribe and Frank for helping out taking the minutes. That really helps us get started. We have a very full agenda in place. We have broken it up into 4 areas. First, talking about the use case drafts, the requirements drafts, the architecture drafts, and all the different protocol drafts we have in place. Would anyone like to bash this agenda that we have? Okay, in that case, moving forward, to quickly summarize where we stand since we last got together, we have 17 use cases, 10 of which are in the working group document. We have 7 more in 2 individual drafts that we're going to talk about. We have an evolving requirements draft that we're going to talk about. We had a new individual submission for an architecture draft based on the conversations we had in Yokohama. And I wanted to point out that we have 5 protocol or data model drafts, all as individual submissions. We're going to talk about 3 of those, which are the first 2 that you see listed there and the 4th one you see listed there. We've talked about the 3rd draft before in previous instances. And there is a last draft, number 5, you see listed there, that was a late-breaking kind of submission, and we're not going to have an opportunity to talk about it at this meeting. All those five drafts suggest a protocol that you see listed there. Some of them suggest a data model, and the data model, I would say, is one of those areas where we're going to need some more work. Next slide, please. So just to point out, again, this is the 5th protocol draft we're not going to have a chance to talk about, but I wanted to put it up there to quickly summarize it. It's using IPv6 hop-to-hop options. Please give it a look. Please provide comments to the authors on the mailing list. And should we have time, we can discuss it during the open mic session. Next slide, please. We are running a little behind from our very, very aggressive milestones from which we started. We had initially been talking about requirements and use case drafts being ready by last month. We're not going to obviously make that. And we were talking about having the transport and data model documents done before we went to Berlin. Again, seems very unlikely. So based on the conversations with the authors and editors, we think it's a little more realistic to start targeting the sole time frame for requirements and use cases for working group last call. The thinking, though, talking with the authors and editors, of course, was that we could probably get 80–90% of what we needed done around the Berlin timeframe, but we would leave that draft open for until the November timeframe. Maybe something from the protocol discussions would come up, and we could rev the document in that way. And then looking at the first quarter of next year for the transport and data model documents. Does anyone have any feedback on those updated milestones? Okay, we'll take them and work them out with the AD. So with that, that brings us to our main program, a lot of drafts to talk about. And the first one, I want to turn it over to talk about the working group use case document to Roland.
Actually, this clicker might not work. I didn't get it to work. Kind of screwed up. Right. Which one is yours? I don't think it's gonna work. I'm so sorry. I will watch for your signal, your hand signal. So if you do this, I will be your clicker.
DDoS is easy if we could just get the collaboration technology working. Hi, I'm Roland Dobbins with Arbor Networks, and this is an update on the draft IETF DOTS use cases. This is the 01 draft. Next slide, please. So this hasn't changed. Our goal here is to provide use cases, categories of use cases for DOTS. They can all be CEPE or PEPE. We have the concept of DOTS clients, DOTS relays, and DOTS servers. Next slide, please. In the 01 draft, the use cases are not exhaustive by any stretch of the imagination. They're mainly intended to be illustrative in nature. The use cases in 01 in the presentation that we gave that illustrated those back in Yokohama actually tended to focus on intelligent DDoS mitigation systems, DDoS scrubber boxes, but these use cases are generalizable. They're not tied to any particular detection mechanism, telemetry format, or mitigation mechanism, flow spec, SRTBH, whatever. It's technology independent by design. Next slide, please. So what are the changes that we've made in 01? We deleted some of the repetitive verbiage, not all of it. We added some introductory verbiage to provide more context to really explain the purpose of the document and why it's laid out the way it is. We did some minor additional clarification of the different archetypal use cases that we had there. We did some renumbering. It was not really a major update. Next slide, please. So what's coming in 02? A lot. First of all, we're consolidating this draft with a lot of the elements and concepts in draft Nishizuka DOTS interdomain use cases 1. We're refactoring the document completely. Our real goal here for the 02 is a minimum viable capability, right? So what is required in terms of the communications model, the messaging types and so forth for a minimum viable capability so that organizations, nodes can signal to get help to mitigate DDoS attacks. Organizations doing the mitigations know that they need to perform the mitigations, that status messages can be exchanged, and that then when the attack is over, requests to cease mitigation can be transmitted and acknowledged. One of the things that we're going to do with 02 is write use cases that are more like stories. They're more prosaic. The steps that are in the 00 and the 01 use cases that list step by step what the communications signaling looks like between the DOTS client and the relays and the servers is useful, but it's very abstract. And we want to make this accessible to everyone so that folks who are interested but aren't DDoS specialists can really understand the context. And that's a major goal of 02. The current use cases that are in 01 are going to be simplified. There's going to be further deduplication, and they're going to be moved to the back of the document in an appendix, right? Because it is valuable to have those communication steps listed out, but it's even more valuable to have context first. We're going to include combined components, exchanges, and processes so that we really tell a complete story in each use case in the 02. And we also have some additional co-authors coming on board. Next slide, please. So in 02, we're going to produce a working model of what's currently possible, along with some sensible evolutionary, not revolutionary enhancements for what we're calling DOTS Phase 1, which is the initial capability for DOTS. We're also going to talk about some additional functionality which may be useful, may be desirable, but is not necessarily mandatory. We want the document to be accessible and so that it can be understood by non-specialists, folks who don't focus on DDoS. We want to broaden the participation and get more viewpoints of different types of operators and different types of scenarios into the document. We want to have a single document so that we don't have to send people to this use case draft or the other use case draft or what have you. We'd really like to have it in a single document so that it's much more accessible and more easily referenced. And so this is 02 will be a major update. Next slide, please. If you want to download the presentation, here's a QR code and a short URL as well. And I believe that's all we have. Questions, comments? Hi, Linda.
Linda Dunbar. I sent a question on the mailing list. I read through the use case. I'm not too clear on you have DOS client who has the capability to be DOS client, but you don't have any definition of what is that. I'm just curious, like, can you give an example in your document?
Well, sure.
For example, here is a router or here is a device.
Right. That was actually, I believe, answered on the mailing list, but so basically the potential is that anything with an IP address can be a DOS client. So it could be a router, it could be some system that has a way to detect and classify and trace back DDoS attacks. It could even be a device that mitigates DDoS attacks. It could be an application running on a server, like a web server daemon or a DNS server daemon or something like that. So it could be an app on a mobile phone. So anything that has an IP address and a processor and memory can potentially be a DOS client. Hi, Daniel.
So Daniel Erickson. So if I'm correct, it's something that's going to be clarified in version 2.
Correct.
So that would be great to have the feedback on the version 2. But
that's exactly what we want to do in 02 is to tell that story so that it's more clear.
And that's exactly what I was going to say, Bob Moskowitz, that we're going to have start out the section on what are the components and identify what the components are. What are the types of DOS clients that you'll see, and try to group them into classifications. So that we realize we'll be doing next.
Right. Excellent feedback. Any other questions or comments? Okay, yield my time back to the chair. Thank you very much.
Thank you. Thank you to the whole team. This looks very good. Next one up is...
Konami is up.
Yep.
Is this the right one?
Yes.
So I have no clicker, but I will react to your hand signals.
Okay.
Yeah.
If you could just stand up.
Yeah, hello, I'm Kanami Nishika from NTT Communications. I'd like to introduce my use case draft. Next, please. I need some place. This is not MacBook. Here is a list of the revised points from 00 version to 01 version. First, the terminology is aligned with the existing requirements draft. So the proprietary terms are removed, so it became easy to understand. Second, the section of DDoS protection methods are added. I will talk about this later. Finally, I clarified the use cases based on the feedback at the IETF Yokohama and the discussion, even on the mailing list and direct message. Next, please. Here is the categorization of use cases. In intra-domain use cases, DOTS elements and mitigators are in the same organization. On the contrary, in the important characteristic of inter-domain use case is that the DOTS server and mitigators are in a different organization from DOTS client. This characteristic would require that appropriate information should be conveyed from one organization to another in order to make DOTS signaling work well. Then inter-domain use case can be divided into customer to provider case and provider to provider case. The difference of these C2P and P2P use case is intensively discussed on the mailing list. At this time, I enumerated use cases with this categorization because I think there is a difference in the aspect of optional information. I will explain it later. Please. So here is the primary scenario of inter-domain use cases. In DOTS signaling, it's red line, they need to exchange information between organizations. Those informations are required by DOTS server to protect the service by various protection methods, especially the destination address information of the attack traffic is a key value for the DDoS server to determine the request is valid or not. Also, status of information should be returned from server to client to determine whether the attack has ended or not. So this slide summarizes the studies about the DDoS protection methods. In order to make protection methods work properly, these information should be provided from DOTS client to the DOTS server. Required information vary according to the protection methods. However, it is not intended to specify how the DOTS server communicates with the mitigators, nor how the mitigators mitigate the attack traffic. Also, DOTS protocol should be independent of these methods for future extensibility. However, we need to find mandatory information which are common among at least existing protection methods. DOTS signaling will not work without such minimal information. We have found that some consensus that the minimum information in DOTS signaling is help me. In this case, me is the destination IP address of the attack. However, some of the existing protection methods require more information. For example, filtering and BGP flow spec will not work without the designation of 5-tuple and action rules. This information would be, say, conditionally required information from DOTS client to DOTS server. And also some of information like BGP community of selective RTBH, desired countermeasures, next hop address of detouring technologies are optional information. They may or may not be provided to DOTS server in advance. Next, please. So attack telemetry is a set of summarized traffic information which categorizes the feature of the DDoS attack. It implicitly indicates the reason why the DOTS client assumes that the observed traffic contains the attack vector. How this telemetry can be collected is out of scope of DOTS. Again, destination IP address is key value which identifies a series of DDoS attacks. The rest of attack telemetry is optional and may be used by each protection method. Okay, about the DDoS protection status, especially in the case of inter-domain, the monitoring point of DOTS client and DOTS server is different organizations. So sometimes it is difficult to know whether the DDoS attack has ended or not by the DOTS client. For example, if the protection method was RTBH, the attack traffic will be dropped at the ingress router of a transit provider. So there is no way to know whether the attack is ended or not by a customer. Therefore, the listed information should be conveyed from the DOTS server to the DOTS client. First, attack telemetry should be returned to the DOTS client periodically for the decision making. In addition, the operators of the service will be eager to know what kind of attack was attempted. Then they can study the best plan to cope with the attacks in future. Second, status of protection, which is ongoing or stopped, needs to be informed from server to client. Finally, especially in the inter-domain use case, there will be some contract between two organizations. So some kind of information like dropped traffic, number of execution, etc. will be used for billing. However, the defining data for billing is totally out of scope of the DOT, I think. So here's the categorization of the inter-domain use cases. As I said on the first slide, the draft classifies inter-domain use cases into two categories, which is C2P and P2P. The use case 4 and 5 is covered with another draft, so it will be explained at the next presentation. Okay, this is I already talked in the IETF95. So this single home model is simple and basic use case. It is customer to provider model. Next, please. In this multi-home model, there are one DOT client and multi-DOT servers. It is also customer to provider model. Multi-home model is including previous single home model. So this delegation model includes the provider-to-provider signaling. If the capacity or capability of the protection system of the provider in the middle layer in domain B is insufficient, they can call for protection to other provider in other domains. Also, it is effective to delegate the protection to upstream domain, because stopping DDoS traffic at an ingress border will reduce unnecessary forwarding. The question is that information conveyed from customer to customer, from provider to provider, is customer to provider and provider to provider is the same or not. The minimum information, the information about the target and the attack, should be included in both signaling. Then how about the optional information? Monitoring point is different, so the DOTS element in the domain B, middle layer, could overwrite the information about attack traffic monitored in the domain A. So optional information could be changed in case of provider to provider. In addition, how to select the appropriate provider which offers appropriate protection method is a coordination problem of this use case. And finally, regarding to the returning path, the mitigator in domain C can return the legitimate traffic to domain B or domain A. It depends on the protection method selected by the provider C. In the former case, the attack traffic could re-enter the protection system of domain B. In the latter case, the returning path information to domain A directly might need to be registered to domain C in advance. Okay.
Fleming Andreas, just a question for clarification. So in your view, would it make any difference whether domain B had a relay or a DOTS client server as you're showing here? And related to that, the DOTS client in domain A, is there a difference to him as to whether domain B forwards things to domain C or not? Is that something that in your view is something the DOTS signaling should take into account? Or is this just essentially an architecture that's overlaid on top of it, and domain B is just, implementing some, client server thingy on their own, and they have some contractual agreements in place with their client? Like, how much of this is in scope of the overall DOTS group and the solution?
Yeah, I think I talked with Roland. The minimal information is signaling, and the minimal information should be relayed with unchanged manner from customer to provider and then provider to provider. However, optional information could be used as the helper for the protection method. So provider in domain B can use those optional information to ask for help to the other domains. So I think those kind of optional information should have the kind of data model, and it should be treated as optional information to include it in DOTS signaling.
Okay,
Yeah.
thank you.
I'm cutting off the line for this draft.
Roland Dobbins, Arbor Networks. So all of the elements that you listed previously, the information elements, if you can go back a couple of slides, please, Chair. One more. Yeah, right there. Okay, so like this, for example, all these are absolutely things that are utilized in DDoS mitigation, right? And they are things that many of them have to be set up and provisioned ahead of time. I agree with you that these are things, and these need to be noted in the use cases we're going to be working on for 02. But all this stuff, in my view, does not belong inside DOTS, right? Because a lot of this is out-of-band administrative stuff. And then there are other working groups with whom we need to collaborate, like I2NSF, for example, maybe I2RS, right? And so I think it's fantastic that you have listed all of these things out here, but I think we just want to clarify for everyone that these are things that are necessary in many cases for DDoS mitigation, but we're not looking at cramming all of this into DOTS itself, but we want to enumerate it all. Is that a fair statement?
Yeah, it's clear.
Okay, thank you. Right, Chris's comment is that the client's not going to know all of this stuff because this is policy stuff that's out of band, that's wrapped up in the network operator. So just to clarify for everyone.
So my comment was mostly the same as the one made by Roland. In addition, I'm also not sure how DOTS feel into the sharing information between the domains. So that's something we will have to clarify and to see where DOTS is regarding to I2NFS, for example. So that, I don't have the. I don't have any. I'm not saying we're not, but it's something we have to clearly consider.
We have another draft feature. Have the documentation about such kind of the information between the provider and provider. So I will talk. I and the plan to talk about that later, and then we can discuss that. Which is overlapping with the.
But I mean.
So sorry for I'm answering to your question. So as with regards to coordinating with I2NSF, yes, the chairs are working closely with the I2NSF chair to see where things end and that we have nothing dropping between the gap. It's like we kind of have avoid overlap, but on the other hand, we also don't want to have a chasm between the two. So yes, and as work progresses, we will see where the things fall.
But in my understanding, with DOTS, the server will always be aware of the traffic. So not necessarily. Okay.
This is Linda. You have a slide showing the BGP flow spec is not working properly. Can you help me understand a little bit why it's not working properly? Because today, lots of deployed system using BGP flow spec to achieve the mitigation.
Sorry, maybe it depends on my kind of my part English. However, I didn't say that the flow spec will not work. I just saying that without the designation of the flow spec will attack. So that's my statement. So without flow spec requires the designation of the flow and action rule. So both are required. So,
I'm cutting the mic here.
Okay. I'll talk to you later after after the session.
It's just we have a lot of presentations and thank you.
Okay, please, use case 4 and 5 will be presented to the next in the next slide. So next presentation. So skip to use cases and final slide. Okay, final slide, please.
One more.
Next one more. Next step, this draft will be consolidated with a working group use case draft. So I'll be a co-author of the working group drafts. So text and context will be merged. So comments to this presentation and my draft will be included. Thank you very much.
Thank you very much. And we move on to your next presentation.
Yeah.
So you will stay here while I load the next. This one? Yeah. The domain, yes, this one.
Was that yours, Frank?
Yeah, maybe.
Is this the right side?
No,
Oh,
no.
sorry.
There's another presentation.
Too many presentations.
Yeah.
For the clarity of the working group, in that case, in this particular draft, there's both use cases and a protocol. So we've split these conversations up, one half for the use case, one half for the protocol.
Yeah, correct. Yeah, this presentation was divided to me and Frank. So I just talk about the use cases in this draft. The draft name of the draft is Interdomain Cooperative Use Protection Problems and Mechanisms. Next, please. So the motivation of this draft is that increasing attacks will exceed the capacity of the protection system of one organization in the aspect of the volume and frequency. So this cooperative DDoS protection utilize other organizations' resources each other through DOTS to share the burden of the protection. So again, this draft describes one architecture and problems and two protocol of the cooperative DDoS protection. So I explained about the former as a use cases. So in this cooperative DDoS protection scenario, two or more DDoS protection service providers are cooperating with each other via DOTS protocol. The draft is now focusing on the relationship of those providers. In distributed architecture, there are full mesh or partial mesh bilateral relationships between service providers. In centralized architecture, there is one orchestrator which has bilateral relationship to service provider. Then it coordinates the cooperative protection. So in this distributed architecture, a DOTS client can ask for help to the DOTS server in its service provider, say provider A. Then the DOTS server in that SPA delegates the protection to add to the DOTS server in SPB. So then the DOTS server in SPA can delegate so the mitigator in SPB protects the customer of SPA. On the other hand, the DOTS server in SPB can also delegate the protection to the DOTS server in SPA. So in this model, the DOTS element in domain A and B is delegating the protection each other. So if the capacity of protection of domain A is 300 gigabps, and also B is also 300 gigabps, they can cope with a 600 gigabps DDoS attacks in total.
Sorry, Chris Morrow. So I have a question. A lot of this looks like I'm a customer, you're a provider, he's a provider, but you're a customer of him as well through some cooperative agreement. Or you could model this as VeriSign has a pod in 701, they have a pod in 7018, they have a pod in 2914, they have a pod in 1239, right? There's not really any difference in that. And VeriSign could say, I want to sync all of this traffic in 701. Oh, it's too much. Let me have half of it over here in 7018, right? There's not a lot of difference between this. So I would just say this is just client and server, right? It's all client and server. So you're outlining a more complicated picture, but it's just client and server, and it's just cooperative between the providers here, right? So in a large network like Google's, we could say, we're happy to do this all ourselves. We go, oh God, we're not. Please save me over there, somebody, right? And then they might say, oops, it's too much for us. Let's pull their peers or upstreams or equivalents into the picture. It's still just client server. So
Yeah.
and then essentially, like the originating client doesn't know anything about what's going on above them, right? And the DOTS messages so far have not talked about, please don't leak my request beyond your border. So, which I think actually you don't want to do anyway. So I think all of this is just client server. So I would say it's not really any different than what we already have defined. I haven't seen what's different. So show me what's different.
Can I?
Yeah.
Yeah. Just a response to Chris, your comments. I think you are right. Here, I think the basic relation is DOS client to DOS server. That's all. Yeah. But here we just want to clarify the different possible scenarios that how to use these very atomic relations to in different way. Actually, this page is maybe you can see it's a very traditional way that the two operators have the client and the server relation, and I ask for your help. So you can see our architecture, our abstract figure that we all the relations is between the client to server. So I think we are not contradictory. So yeah, but maybe in the next page, it's a little bit different. It's not the simple peer-to-peer, operator-to-operator relation. It's maybe in theory we can have a centralized controlled orchestrator to help to facilitate the relation, the client-server relations, to make it more efficient or make it more have an overall view to help the decision better. So that's just how to use the relation. It's different, but actually you're right. Yeah.
Right. First of all, concurring with Chris's comments and a couple of additional observations. First of all, a cooperative DDoS mitigation does not necessarily require that the various networks involved are topologically adjacent, that they peer with one another. They can be, widely distributed across the internet. Secondly, and it seems that, it visually looks on the left-hand side that they have to be topologically adjacent, but the truth is that they don't have to be. The second thing I want to point out here is that when you have these different networks that are involved in these mitigations, in many cases they are using radically different technology to do this. They may use completely different telemetry formats, detection, classification mechanisms, mitigation mechanisms. And so when we talk about, okay, we're going to start coordinating between like two or more providers that are mitigating an attack, that's great. But what we need to think about is the lowest common denominator that can always be understood, right? Irrespective of the various technologies that they may be employing. And that's basically a status message saying, hey, I'm mitigating an attack for 172.19.254.1. And then all the rest of this stuff is out of band and gets in, again, into the realm of I2NSF and I2RS and so forth.
Fleming Andreasen. So I'm going to disagree. I think there is actually a very important distinction, and that is once you get into layer 7, you can have scenarios where you are basically handing over keying material to your DDoS mitigation provider to enable him to actually do DDoS mitigation on TLS traffic. Once you get into a scenario like that, I think it makes a big difference as to whether you're in a single provider scenario that you have contracted with and you understand what's going on there and what jurisdiction your data actually resides in, versus just saying, I'm just going to, contract with somebody else all over the world and give them the key material as well. So I think there's, a key distinction there. For layer 3, layer 4 only, yeah, you're probably right. But I don't know if we're necessarily restricted to those use cases only, at least not going forward.
Just going to quickly interject, cutting the line at Roland.
Alexander Levin, just a quick note, as was mentioned, radically different technologies will provide radically different results, especially for layer 7. Who and how will follow up on the false positives in the grand scheme of things?
Tobias Gondrom, Working Group Chair, Head of. So I agree that the minimum is the common denominator, as Roland said, and that many of the systems are quite different in how they work. However, there are also some overlaps and commonalities. And if I would be looking as a customer towards a network of providers, actually, I would like to have a little bit more ability to coordinate if possible. So yes, the common denominator is the minimum, but if I can have more, I actually want more. So I would want the possibility to have more coordination, more exchange of information, because I believe that would be beneficial if it's optional.
Yeah.
Roland Dobbins, Arbor Networks, 2 meta comments. Yes, Tobias, agree with your comments completely. What we want to, I think what we want to do establish first, though, is the minimum viable capability, and then let's build on that. Right. So there is some element of futures here. Fleming brings up a very good point in his example of encrypted traffic. I do want to point out, though, that mechanisms for doing that and so forth are not really inside DOTS itself, right? That's out of band from the messaging system perspective. Yeah, there are other mechanisms, to do that, and exchanging, SSL certs and private and public keys within DOTS, I think, is a bit of a stretch.
Good. I hand back to the speaker to continue the presentation.
Okay. Yeah. So as Frank said, here is a slightly different architecture, which called a centralized architecture. If the number of providers are involving this coordinating protection increased and letting them make mutual relationship between each other, it became more difficult and complex to select appropriate DDoS protection according to the capacity and capability of each mitigator. So centralized architecture model is another multi-provider coordinated DDoS protection, which could overcome the disadvantage of the distributed architecture. In this model, one DOTS element can be orchestrator of other DOTS elements. For the coordination purpose, the centralized orchestrator can select appropriate service provider while checking capacity and capability of each service provider's protection system. So this is move on to the last slide. Yeah, so as mentioned in the mic line, there is a complexity in this DDoS protection, cooperative DDoS protection. So there are many challenges for the inter-domain cooperative DDoS protection. So first, there are problems relating to the provisioning. It will take much time to provision the DDoS protection system if it is manual. So automatic provisioning of each other's facility is desirable. However, how to trust each other and securely set up the channel is a big challenge. Second, again, there are coordination problems. So how to get the appropriate mitigation service from other providers is the problem. The decision will be made based on the information shared by other providers. Mitigating and filtering traffic at the nearest ingress point to attack source is desirable. So if there is cooperative partner near the attack source, asking for help to that ISP is most effective. However, the problem is that it's difficult to decide which ISP is the nearest to the attack source, because in many cases, source addresses are spoofed And moreover, the topology information would be hidden because of the privacy protection. Also, there is many problems as a returning path problem, and also there is, as I said, accounting problems. So solutions to these problems will be treated in the next Frank's solution presentation. So this could be the answer to you about the complexity of these use cases, and it could be treated as different use cases to cope with those problems. Thank you very much.
Okay, thank you. Please.
Hi, Dave Dolson, Sandvine. I'm wondering if any part of this use case requires methods for the client to determine where the attack is coming from. If a client has multiple upstream sources of data, seems like maybe some telemetry from the server side to the client might be useful. Like, do you have any thoughts on that?
Yeah, I think it is not always customer have multi-service provider, so if it has only one service provider, it only can ask for help to that provider. However, that provider can share the burden of the protection with other provider, and it leverages the total protection capacity in total. So this is the point of the piece.
Rolling Dobbins over network. So a DOTS client could be very well informed with full detection, classification, traceback capability, or it could be something as simple as a panic button app on a smartphone that somebody says, oh, the internet's down, maybe I'm under attack, and pushes the button.
I'll be cutting the line here. So please,
Okay.
everybody's standing. No, you can stay. Cutting the line means and nobody else in addition. Please.
So I don't think my question was answered. You know, I think it's quite clear a device can know it's under attack, but I guess one approach is just it should ask all its upstream providers for help. But there's also it was mentioned the use case where the help may not come from an adjacent network. So my adjacent network may not have capability, but I may want to ask for help, from across the internet. There's a lot of places across the internet, so you don't want, I don't know, is it necessary to learn where it's coming from, or just ask for help everywhere?
Okay, Frank, Xia, just I think respond, Dave. I think your question makes sense. Yeah. Actually, if we can share more information about the different operators, we can make better decisions. But I think your question is more related to the distributed use cases that many operators are there, and they have a peer-to-peer relation to share their capability, their resource, their location information among each other. And if the DOS server side can send some of its information to the DOS client, the DOS client can know which can I get the help. Yeah, that is maybe a possible way, but I think there are some problems for this, because if actually in our case, in our condition, we want to make the mechanism and the fingering is to be simple, to not have so much messages exchange each other. So I think the basic way is that just the client to send his information to the server and ask for help. So let the server to decide what to do. I think that's more reasonable.
Okay,
right
I will allow you a second. No, I will allow you to come in, but please be brief. Okay. Yeah.
Very quick, just saying the scenario you're talking about is a bit different than the focus here. It's really provider to provider. I'm a customer of
Name, please.
but it's different. Name Lu Yanfang. Thank you.
Thank you. And we can continue this on the list as well. Please.
Alexander Lemin, speaking from my own experiences, in cases such as this, hierarchy spells trouble. Please stay away from hierarchy because it will make debugging impossible.
Okay, thank you.
Yeah, thank you.
Yeah, and with this, we move on to DOTS requirements with Andrew, please.
Yep.
Thank you very much for the presentation.
Good morning, Andrew Mortensen, Harbor Networks.
Another one?
Other one. Yes, this is the black and white draft. This is an update on the working group requirements, version 01. So just a brief overview of the changes in the 01 draft. We've revised some of the text in the introductory sections, particularly the overview, which is now a context and motivation section. Moved some of the requirements text from that section into the requirements section itself. We've got some updated terminology, some added terms, some clarifications, and some updated requirements themselves. Next slide, please. As I mentioned, we've altered the name of the overview because it's much more of a context and motivation, migrated the requirements text itself into the requirements section. Next slide. The added terminology comes largely from the 00 use cases draft. We made some effort to reconcile that language so that we have a common understanding of the terminology in use across all the drafts. The three you see here were the added terms that came from the use cases draft. The updated terminology, DDoS obviously as well, had to be reconciled with the use cases draft. We've also tried to clarify what seems to be the working group's common understanding of the sort of basic functions of the DOTS relay here by highlighting the bridging and the signal aggregation. The requirements section itself has an introduction now where we try to emphasize the DOTS client's control over the mitigation. And in particular, we've tried to make it clear that the DOTS client needs no justification to request mitigation. It can do so roughly at the whim of the operator, assuming the service agreement's in place. And it can also withdraw a request for mitigation at any point, subject to some protections for the DOTS server to prevent things like route flapping or DNS flapping. We also tried to address some conversations around QoS that took place on the mailing list. QoS is certainly something that could be in place between a DOTS client and a DOTS server, but DOTS can't assume its presence, especially if we're talking about a DOTS signal sent across multiple transit networks. The general requirements section has been chopped down a little bit. We did remove the interoperability requirement. Ned Bugadir pointed out that since DOTS is motivated by the lack of interoperability, this was redundant. We've also added a subnote about the unidirectional messaging required within the bidirectional channel. The idea being that the server will need to send notifications, for example, and sort of made it clear that the data channel must be a reliable transport. Next slide. Operational requirements received the most significant updates. We've emphasized the use of the connectionless protocol with the fallback to TCP. And we've added several new operational requirements, including redirection, mitigation lifetime, the idea that the DOTS clients can say the lifetime of this mitigation request will be n seconds or minutes or indefinite. And depending on service agreements, that will go on for a certain amount of time or indefinitely. We've extended the possible addressing modes for mitigation scope, and this is going to have some implications, which I will get into a little bit more in the architecture draft. But we've added discussion of things in addition to IP addresses and prefixes, things like FQDNs, URLs, URIs, E164 addresses, and so on. And we've also emphasized that the attack details from the client are optional. What the perspective of the client on an attack may not be very broad, and so what it sees as the nature of the attack may not actually be an accurate representation. So the server may take those attack details into account, may ignore them. We have a new operational requirement for mitigation efficacy. This is a report from the client on its sense of the effectiveness of the attack protection that's been undertaken on its request. And then we have conflict detection notification. This would be the case where a client has requested mitigation for overlapping prefixes, for example, and the server should report that. We have some lookup caching requirements here, the idea being that under attack conditions, performing lookups, DNS, PKI chains, and so on would be difficult. And so the client should, as much as possible, try to cache that information, and that the protocol must support NAT traversal.
Hi, Andrew. I have a question about the confliction detection and notification. Okay. I think this should not include the confliction resolve or something. It's just to find some confliction, and I don't know what can the protocol can do for this confliction notification. So do we need this kind of work?
I
You
don't disagree with you. I think this does need some more discussion. And I can talk a little bit more about that at the end. But this does seem to be a place where, in the case of prefix overlapping, the server could do the smart thing and merge them. For example, if you have a /17 and a /16, and /17 is part of the /16.
Yeah. Okay.
Fleming Andreas, on the lookup caching, I was a little confused when I read that in the document. Are you suggesting that we ignore TTLs in DNS responses?
I'm sorry, what the
Time to live in DNS?
ignore what? I'm sorry.
That we ignore the time to live indication in DNS responses. You talk about lookup caching. It wasn't really clear to me what you were saying there.
No, I don't think so. Bob, do you want to address that?
It's actually worse than that. If you're under attack, DNS may be totally inoperative, that you can't even expect DNS to work. Therefore, what you're going to be doing in terms of DOTS messaging has to be, after you resolve the addresses, you're using the IP addresses. If you just resolve the FQDNs, you can check them up periodically when things are working, refresh your cache on a regular basis, but you cannot make an assumption that, oh, I can do a DNS lookup here to find out where I'm going to be sending the message to. You have to assume that that will not work.
Which cache are we talking about? Because you answered a different question.
Andrew?
That is a good question. I think, so this was driven by an understanding, for example, if you have an ongoing session and it disappears for some reason, possibly under attack, and if you do not have the domain name cached, trying to do a DNS lookup, again, when you're trying to reestablish the connection. Yeah.
So how you maintain that information in a DNS cache or however you do it, you have to do in a way that it will work. However your implementation works, it has to work in a way that under attack, you'll still be able to know where to send the messages to. Okay. Which means doing a DNS lookup really should not be part of your method to use. And if TTL is expired, you have to, it's in the cache, you have to assume, well, hopefully they are still there where it says they were.
Okay. Closing the mic after Daniel, and I appreciate brevity. All right, let's discuss this one more on the list.
I agree.
Absolutely.
Strong suggestion that use of DNS for DOTS peering configuration be discouraged, deprecated. This system should not require name resolution in order to function. It should be based on IP address.
So maybe Daniel Erickson. So maybe that can be discussed on the mailing list, but I was a little bit concerned about the timestamp for how long the mitigation is going on. Am I correctly understanding?
This is this is sort of a late addition, but you're talking about the mitigation lifetime.
Yeah.
I again don't disagree with you on
Okay.
that. I think there are some operational concerns that would need to be discussed, particularly if it's a situation where the mitigation is about to expire. Say the DOTS required an hour, asked for an hour, and wants to renew it, and it doesn't get through.
But actually, you can't say if you want to renew because you're maybe not aware you're still under attack. So okay.
I agree. The data channel requirements received sort of minor updates. We've moved the mutual authentication requirement to a separate security requirements section because there was some overlap there and with the general requirements. Clarified the possible use of the data channel for black and white list management, but we really need a lot of feedback here. It'd be great to get a sense of the working group's understanding of the role of the data channel and possible missing requirements here. We've sort of alluded to things like vendor extensions or configuration, but it would be valuable to get some more feedback here. Next slide, please. And as I said, the security requirements, these are all drawn from other requirements. They haven't changed, they've just been moved to a new section. So next steps, it's going to be very important to align with the 02 use cases draft because that, as Roland and Kanami have mentioned, it's going to be a fairly significant overhaul. We'd like to keep the requirements in line with that, refer to the new use cases language and specifications. And you may have noticed that the data model requirements are not here. We removed the subsection. We've gotten no input on this. And so we really need to start talking about where this belongs and what it will contain.
Hi, David Olson, Sandvine. I didn't see any mention of the methods of mitigation. Blocking is assumed. Is it also possible to request shaping or to request, say, 90% of the traffic to be blocked? Or is that considered out of scope, the actual method?
I think that's, my sense is that's out of scope. I mean, that would be part of a service level agreement between the client entity and the server entity because the server entity may not have the capacity, for example, to do what the client is asking.
I was just trying to think about if a client wishes to, say, let some of the traffic through and because some of it might be useful or
that might go into some like the data channel discussion. That might be a great way to.
So that might be in scope for the client.
Yeah, I think that's what this
hinting at what sort of level it wants. Okay.
That seems possible. Obviously, we need to incorporate more working group feedback. We've gotten some very good feedback, but the breadth has not been very wide. We have a few people who have contributed a lot. We'd really like to expand the input from the rest of the working group. All right, thank you.
And I'd like to reiterate the comment about the data model. Where we have the most work is in the specific solutions-oriented drafts, but kind of generalizing that out for interop, what would we like to see in all the different solutions draft would be a great help from the working group. So please do drop your comments on the mailing list on that topic.
Okay, and I think you are up next again for the architecture.
All right, so this is the full color slide featuring green. So we've put together an architecture draft largely to address what we saw as the need for some sort of common understanding about the roles and relationships involved here. There's been some confusion and some debate on the list, and we're trying to sort of define those, drive some debate around that, and help the working group come to a common understanding. Next slide, please. All right, so a quick overview of the draft itself. We are defining the roles and relationships in a DOTS architecture. We're really trying to set the architecture scope to really define where we need to focus the attention in our work in this working group. We discussed some of the preconditions for signaling. Obviously, we're not really requiring anything, but we're talking about some of the preconditions we assume need to be in place for a DOTS architecture to be functional. We go over some of the steps involved in establishing and maintaining signaling sessions and some modes of signaling, which involve the relationships and how the different elements are communicating. So this is the very basic architecture, and the two elements there in the blue oval really are the scope of the architecture, the interfaces between the server and the client. It's assumed that there is some sort of attack target triggering a DOTS client, and it may just be an operator manually sending the signal as a result of a detected attack, or turning it on an anticipated attack, and that there's a mitigator that can do something on behalf of a client's request. But the focus of the architecture is between the server and client. Next slide, please. When we're establishing signaling sessions, the client itself is going to do the initiation, and the draft does not make any specification about whether that needs to happen over the signal channel first or the data channel. It does suggest that both should be operational before the client considers everything operational. But it's really to allow a measure of operational flexibility, particularly where the client is being provisioned or brought up during an attack, and trying to communicate over the data channel may not work well. We could use some working group feedback on the value of DOTS service discovery. This would be the case where a DOTS client is brought up and is given minimal information, perhaps some keying material to authenticate itself to the DOTS server, and then can discover the rest of the information it needs from, for example, a DNS service discovery to set up its signaling session with the server. Next slide, please. Direct signaling is the mode that we've identified that will be simplest. This is exactly that client-server model that was discussed previously. There are no relays in the path. This is simply a DOTS client and DOTS server that are logically adjacent. Obviously, there may be other elements in between them in the underlay or NCAP and so on, but logically, they are adjacent. Next slide. Relay signaling has caused a lot of discussion on the list, and we still need more information about it. The two cases we've identified, as I alluded to in the requirements discussion, is signal bridging. So there's a protocol, let's say downstream it's UDP, there's a TCP session, whereas the upstream is going to be a UDP session, and the relay acts as a bridge for that. And then aggregating multiple downstream signaling sessions into a single upstream signaling session. Next slide, please. So relay signaling does bring to light several issues. Operational complexity is not the least of them. Each relay that you add does bring to light things like, similar to what Fleming was discussing about the L7 issues. Is a relay delegated to request mitigation on behalf of a client? Does it require the authentication material and so on? End-to-end signaling, you may have seen some of the debate on the mailing list. I think we still need more discussion on this. Does the client need some insight into relay signaling, or is it just completely opaque to it? It just knows about its adjacent DOTS agent, and particularly the privacy considerations. What information, if in a bridging mode, for example, the URIs that might be in the requested mitigation scope are going to be visible to the relay before sending it to the next hop. We really need a lot of feedback here. Next slide, please. So the simple DOTS agent relationship is direct signaling, but when you start connecting multiple clients, for example, to a server, or multi-home DOTS client to several DOTS servers, you have some additional issues. Next slide, please. Particularly, this is the thing that we were discussing about if you've requested mitigation from all of the DOTS servers to which you requested, and several of them say, yeah, I've started mitigation on your behalf. How do you coordinate those? What impact is that going to have on the client's domain? And in general, we do need some more feedback on the many-to-one and one-to-many cases. Next slide. We've also discussed some additional signaling modes. The redirected signaling is just simply one DOTS server telling a DOTS client that's connected to it to cease communicating with the DOTS server and establish a new signaling session with another DOTS server. And then recursive signaling actually looks very similar to some of what Konami was discussing, where a client is asked one domain to start mitigating on its behalf. That domain, for whatever reason, decides that it needs some help and sends using a separate signaling session, asks a separate provider for help using another DOTS signaling session. So next steps, I do have some text discussing the sort of triggers for mitigation that might be involved in the DOTS architecture. So that may be valuable to bring forward in the next revision. And we really need a lot of discussion around the privacy concerns. When we're talking about including such things in the mitigation scope as URIs, as E164 numbers, even domain names, that does expose a lot of information, a lot of metadata, and we really need to be cognizant of those concerns. And we look forward to incorporating some working group feedback. Thank you. Any comments or questions?
Roland Diamonds, Arbor Networks. Everybody certainly is rightly concerned about privacy, but it should be noted that in order for mitigations to be effective, right, that a certain amount of information has to be shared between the organization requesting mitigation and the organization that is doing the mitigation. But if we take a look at what's really required to get mitigation going, in many cases, there's not even going to be a need to ship that kind of stuff across DOTS. But if we do end up in a situation where, in a future DOTS deployment, that URI information, domain name, domain record information, whatever is sent across it, this actually kind of goes back to the discussions about bilateral versus multilateral, that today pretty much all these relationships are bilateral. And it looks like because of the limits of technology outside of the scope of DOTS, that it's going to continue that way for quite some time. So that kind of helps minimize some of that concern, because we're not putting it out there for random third parties who happen to have DOTS to see.
And Dan Wang, you wanted some feedback. Let's get rid of relays.
Thank you.
So this is Tobias as co-chair. A technical question. Or
or it's kind of a technicality. This draft so far has not yet been adopted by the working group, but it's basically writing all the stuff that we do for this working group. So I wanted to ask maybe a quick show of hands, who has read the draft? Okay, so the chairs will propose to adopt this. Are there any objections to adopting this draft? Okay, then with no objections, the draft is adopted. Thank you very much.
Thank you.
Perfect. And we are a little bit ahead of time, so this is really good.
I don't tell them.
Okay, I shouldn't tell you, but yeah. So the next one is Dan Wing for Ready Dots Transport.
So we're now shifting to talk about all the different solutions-oriented drafts.
This
I'm Dan, and talking about our draft ready DOTS transport version 3. Next slide, please. So a quick summary on the changes we made from 01 all the way up to 03. So there was a lot of discussion on the mailing list on how to do fallback and switching between V4, V6, TCP, and UDP. So we took a lot of the ideas from the Happy Eyeballs RC, applied that to both V6 and V4, which was easy, and applied that to UDP and TCP and have a message flow and some more detail on all of these. And talked about the DOTS signaling channel in more detail and the DOTS data channel in more detail. We're just looking at running things over UDP, running things over TCP, and nothing any more different than that. The thing I wanted to get some feedback on the group from is using COPE, and the reason that we chose COPE. I have some detail on that, but interested in getting feedback on that. So moving from HTTP to COPE to try to meet what we understand to be the requirements that folks have. And then the performance considerations, the things to do in the client and the things to do in the server that make things work faster, make things, fewer round trips and that sort of stuff. Next slide, please. So the Happy Eyeballs-like technique tries to do V6 most preferentially, then tries to do V4 as a second thing. So if timeouts occur, and these are very fast, very aggressive, this is not 1-minute timeouts. These are very tight timeouts that we would be recommending. To give you an idea, Happy Eyeballs suggests a 200 to 300 millisecond timeout. Apple's Happy Eyeballs implementation is a 25 millisecond timeout. So, we can choose whatever we like for these sorts of timeouts. And we're also doing this for UDP and TCP. So when connections aren't being successful, we can try other things. And we would do this during peacetime. So when there's not an attack going on, to find out what the path supports and remember what is going on there. And then it needs to be done again. Not the full procedure, but the paths, the paths that worked during peacetime are the ones that would be attempted when there is an attack. So if we never had V6 working on a good day when we're not suffering an attack, we don't bother trying V6 when we suffer an attack. It's probably not going to work under an attack if it didn't work when the network was quiet. Next slide, please. And this is our order of preference, and it aligns with RFC 3484, which is now 6724, which I can never remember. And then we're trying V6 first, and then V4. Trying UDP first, because that was the working group's preference for what to do. So we don't have the three-way handshake with TCP and that sort of thing. Next slide, please. And the DOTS signaling channel, we're starting to get into the data model and what we're doing there. That's underspecified, I think, in our draft. There's a little bit in there now on what sort of messages that we're sending. So the gets and the puts and the posts that we're doing to change the server state and to learn what the server state, learn what the server thinks is going on for its mitigation that it's performing. Next slide, please. And the data channel, this is only over TLS over TCP. And this is whitelists and blacklists that we're having. So less reactive and more just sort of regular operation that we want to have perform. There's obviously some overlap with some other working groups here. This is where I'm less clear on where DOTS is in scope and where DOTS is out of scope, and we need to shake that out. Next slide, please. And I would like some feedback if we can get some on our decision to move to COPE. So one reason is on the next slide, but let's hold on and keep it on this slide first. So this is a protocol that one way to look at it is a very small, tight HTTP. So messages are smaller, less bandwidth is consumed, but it's a RESTful design, very much like HTTP. If you're familiar with HTTP, COPE looks very familiar. There are a lot of differences. You know, it's not a 5-page spec, but it's also not a completely new, completely different goofball protocol. But it supports a lot of stuff that we would like to do here in DOTS, and seems a little better than HTTP. Probably for the biggest reason, it runs over TCP and it runs over UDP. To get HTTP to do that is a more difficult act. Next slide, please. And the chair's asked us, please.
Just one question. Does it make sense to have CoHAP and JSON, or would it be better to have CoHAP and CBOR? I see CBOR as just a compressed of JSON, but maybe I'm wrong.
That's how I view it as well.
Okay.
We haven't decided, and that can be a further analysis. But I first wanted to get, that encoding layer is halfway in between, this OSI diagram, between the dots, rectangle, and the CoAP rectangle is what encoding that we'd like to use. But yeah, we would need to pick one and standardize on that too.
Hi, Nick Teague. 2 questions. Well, an agreement, really. I agree with you that CBOR, JSON are just variations on the theme. As far as the exchange goes, in a couple of slides back, where you had the 200 OK coming back all the time, what happens if that doesn't come back?
Yeah, we'd have a timeout.
Okay.
Really just like happens with HTTP. You have a timeout and you retry, you maybe connect to another server.
So you just keep going until it starts to come back on. And so if you're halfway through a stream and it's been applied and then you start to redo it again, is that going to cause any problems? Or
yeah, we'll have to take care of that. Clearly, and that will be specified in the transport draft, because it's certainly not new that we have network outages that happen in the middle of transactions. It's not new to DOTS, but it's something that we're much more sensitive and much more aware of because we're in an attack situation. And the chair's asked us to describe where we have running code and where we don't. So there are implementations of COPE available. There's obviously implementations of TCP, and gosh, I got my diagram wrong. That is really embarrassing. Gosh, how silly. Man, get your cut and paste right. Better next time, Dan. And we're all set with TCP, DTLS, UDP, TCP, and IP, obviously. So that's why we just pick those as building blocks. COPE, there's a link down there at the bottom to all the implementations of COPE that are available. And we cover all the use cases except for the attack notification to a third party. And look at how short I made the section titles. Isn't that cool? And finally, we have performance considerations. So this is really just a pointer to work that's going on to make TCP more efficient with the TCP fast open, so data can be sent on the initial SYN. That's supported by several operating systems already, but a lot of folks aren't aware of that. TLS false start, that's actually being included into TLS 1.3, but it's something that you can do in TLS 1.2. So these are all sorts of things to reduce how many messages are sent back and forth for TCP and sent back and forth for TLS and stuff like that. And we recommend doing all these things. This would be something that we'd want to shake out with a working group to see, which of these are useful. What's nice is none of these are necessary for interop. They're just things to reduce how many messages are sent, which is always important, especially for signaling. I think that's it.
Andrew Mortensen, Arbor Networks. I like the discussion around CoAP, but there's definitely a disconnect in the text of the draft and the use of CoAP. A lot of the text in the draft still seems to be focused around a distribution of filters. When I read it, I think this looks like RESTful flow spec in a lot of ways, and I'm not sure that that necessarily aligns with what we're trying to do with DOTS.
Okay, that's fair, and I agree. Yeah, thanks. Any other comments?
So yeah, we are good on time. And I see on the last slide 2 questions on consensus related things. Is this something you want to ask
today? Is this something you want to ask on the mailing list?
Yeah, we can ask on the mailing list. It's useful to get feedback in person because it's really hard, for HUMs to
Yes.
work very well on a mailing list. But we've gone back and forth a little bit on the Happy Eyeballs stuff on the mailing list, and I just wanted to see if the technique that I walked us through here looks like it makes sense and folks like that. And same thing on COPE. If there's some, major heartburn over COPE, licensing, scaling, we love HTTP, make it work over UDP somehow, stuff like that. That's what we're looking for. On this slide.
Before I hand to the mic queue, just a question: who has read the draft? Hands, just a quick show of hands. Okay, so not so many, but it's good that we have plenty. So please go ahead.
Hi, Dave Dolson, Sandvine. Skimmed the draft. Happy Eyeballs, if in this environment, more likely to have a lot of buffering and delayed responses. So oftentimes, I think it was already raised, the question of duplicate requests being processed. I think in the application layer, I saw policy ID. So I guess the idea would be if I use the same policy ID twice, the server recognizes it as a duplicate request. And is that sort of the way you think about the Happy Eyeballs avoiding?
Right. This starts to get into the data model that we haven't shaken out yet.
Okay.
But yeah.
Because just so you know, with Happy Eyeballs, it's not really so sequential, like try this and it fails, then try this. You may get multiple successful.
Yeah, so with Happy Eyeballs, the way it's currently spec'd in whatever the RFC is, it's make a connection, and the first connection that succeeds then has the transaction go over it, so the get or the post or the put or whatever. And we would be doing something like that here. When we're running over TCP with fast open, or where we send it in the first transaction, we could only do a get. When we run it over DTLS, we could also, the definition of connection and when we succeed is a little harder. And when we're doing something that doesn't change server state, like a get, that's easy. When we're doing something that changes the server state, we need to get into a data model that prevents us from, as you say, having two posts or two.
Yeah, I wasn't sure how the UDP would work with,
Right. That gets into the data model. We can shake that out if folks like the idea of trying V6, trying V4, trying UDP, trying TCP.
Hey, Nick Teague. I just wanted to say I have no heartburn over using co-op. I think it's definitely worth investigating. It's designed for constrained networks, and I'm reasonably happy with Happy Eyeballs. So it's just a support. Yeah. But I would echo Andrew's comments on the kind of REST spec slant of the draft.
All right, thanks.
Fleming Andreessen, could you put the sequence diagram up for COPE again? So one question I have is, it's great that we can, message sequence diagram.
This one?
Yeah, that's fine. Yeah, either one.
Oh, sorry.
Oh, okay.
Which time? I cannot hear you.
Good enough, yep. So it's great that this can run over UDP, but do you always require a 200 OK coming back? I mean, is there a way of doing just asynchronous notifications effectively?
Yeah, it's just if we don't get an answer back, we're going to keep sending a request. We need some kind of answer back.
Is there any kind of blocking or anything?
We don't need to block. But we're doing this over, remember, we're doing that post. Let's say the post, and we don't get that 200 OK from the post. We're going to try that over V6. We're going to try it over V4. We're going to try it over UDP.
Now let's assume that the signaling channel is already established. And now we're just into sending actually messages. Right. There's an attack taking place. I'm trying to understand what happens in that case. Let's assume that we actually only have, the upstream working.
Right.
How does that work now?
Well, we continue sending that post.
The same one?
Yeah, probably the same one.
Okay.
It would need to be, a message that is distinguishable by the server as being a retransmitted packet. So we would do that with the same policy number or a sequence number, or that we haven't specified.
Okay. It's not obvious to me that those are the exact semantics we're actually after.
It's not obvious what? Sorry?
That those are the semantics that we're actually after.
Okay.
Because it's a continuous update, as I understand it, right, of what the client is actually seeing and is signaling the upstream server for.
Right.
it's not all that important, I think, that it's acknowledged, and if it doesn't get through the first time, right, that it eventually will get through. At that point, you just want to send a new one that overrides the old one, I think, but I'm not sure. I mean, in some cases, you probably do want it more reliable, right, when you want to say now, the attack is over,
Right.
but it seems like you need both communication styles in there.
Okay. Thanks.
Hi, Lu Yan from Microsoft. I just want to comment on the co-op. I like the idea. I think you mentioned the advantage is lightweight and cover TCP UDP. Until we find something major problem, it's better. It goes beyond what the initially intent use. I think that's a good thing.
Okay, cool. Thanks.
Thank you.
Daniel Erickson. So I don't really care which transport layer we choose. We just have to take the best one. But having a HTTP framework just we have to keep dots simple and not to make this overcomplicated. That's my only concern. But it has nothing to do with transfer.
Okay. Well, taking your comment and Fleming's, we may want to have a different signaling protocol underneath, not co-op, so that we don't have to get the OKs. So, okay, all right, thanks.
Good, thank you. And the next one will be Frank Xiaoliang about Nishizuka dots interdomain mechanism.
Yeah, this one. Okay. Hello, everyone. It's Frank Xia, Huawei. And today I want to talk about the interdomain cooperative DDoS protection problems and the mechanisms. Okay, next page. Actually, I think the initial point for beginning this work is that we know that currently DDoS attack is a global and hybrid and more volumetric attack happens. So for the operators, they need to cooperate together to protect against their service. So that means that we must need the interdomain coordination among operators. That's a very important requirement. Okay, please. So what's the benefits that by the cooperation among the operators? We can see that we can get some level of the resource and the capability sharing among them, which can be their network resource and their anti-DDoS capabilities. They all can share these resources to help each other. And also by this cooperation, we can get the very comprehensive DDoS protection optimization, such as we can handle some near source mitigation and we can solve the interdomain uplink congestion problem. That's the only way to solve this kind of problem for the downstream operator. So basically we can help each operators to make each operators more easy. Also, so in summary, by the cooperation, we can realize a global and on-demand DDoS mitigation service without bandwidth, territory, and resources, etc. Okay, next page. So, okay, I think actually Konami has already introduced some of the challenges, such as the security channel and how to coordinate the operators. So I just skip it. Okay, this is about the from the architectural view, how to two possible ways to realize the inter-operators coordination. Okay, just go down. And here I just want to mention one point: whether we use the centralized way or the distributed way. Actually, there's only the DOS client to DOS server relation in the whole architecture. So that means that the protocol is only one. Only one protocol can support all the different various architecture. That's the key point. Okay, next page. So for the DOS protocol, actually we think that there are two parts that we need to address. First is that about the secure channel. So which should be the signaling channel or can be the data channel. So very obviously that this channel should support the basic security requirement, and it also need to support the mutual authentication among all the peering DOS agents. So there are several ways to implement it. Actually, in our this 0.0 version draft, we choose HTTPS plus JSON as our secure channel to send the message. And let's talking about the protocol and the message. And we divided the various messages into two stages. Some messages for the provision stage and some messages for the signaling message. Also, we also need the heartbeat message between the DOS agents to keep the link available. And next page. Okay, this is about the provision stage message. Actually, here now we have defined the registration message and its responding message and the registration canceling. It's all for the DOS client to register its own name, IP address, its local information to the server, and those information, when those information are finished the exchange, when the attack happened, that those server can, based on this information and other information, to make the decision how to help the DOS client. So I listed our message format below, but I do not want to go into details. Okay, next page is about the signaling stage. So this is about when the DOS client is being attacked, how can it ask for help to the DOS server? So there's a lot of messages can be useful in this stage. The most important is the DOS mitigation request message. So, and when the anti-DDoS process is running, we also need some status messages exchanged among the DOS agents to help this process continue and to make it work better. So which include the from the DOS client to server, which include the mitigation scope update, mitigation efficacy notification, and mitigation terminate and heartbeat. But in the other direction, server to client, the server can tell its mitigation status notification to the client, and the server can tell DOS, yes, the attack is stopped, you can stop. So it sends the termination message. The basic operation that the DOS client send a request to DOS server, and a lot of exchange status message exchange among them during the process, and at last it is terminated. And next page. So yes, this page I list our currently defined DOS mitigation request message format and the status message. Actually, there's a lot of work need to do to make this message enough useful and not so complex. Yeah. Okay, next page. According to the chair's requirement, I think we want to give some background about Huawei's implementation about this part. Actually, we have some running code behind most on the centralized architecture. You see that we have orchestrator and what is the message should be like and how they are processed among them. So we have implemented some of it. And currently this draft is mainly focused on the inter-operator use cases. But actually, finally, we find that it also can be used for intra-domain. Because we only need one protocol. Yeah. Okay. Next page. Next step, I think we still need more comments and feedback from working group, and we need to be aligned with the current working group documents. And I think a lot of very important points need to be added to our future draft about the transport protocol and DOS relay things. And we need to also still improve our message format. Yeah, that's all. Any comments?
Hi, Roland Evans, Arbor Networks. Can we go back a couple of slides, please? Where's right there? Okay. So I'm looking at this, and this appears to be essentially IPFix simply being re-implemented across another channel. If providers wanted to send IPFix between one another, there's no technical reason why they can't do that. Why are we looking at including all of this information within DOTS rather than simply sending IPFix or whatever between providers?
Oh, okay. Currently, we think it's not, you can say it is IPFix, but we consider it just the telemetry information. But there may be too much. We can, we have already discussed that we have a minimal set and we have some optional information. So
if this is some kind of optional thing that two organizations decide they want to exchange, okay.
Yeah.
But when you start looking at, so some of these fields here, like malicious total packets, malicious peak packets, those are very situationally specific constructs. Those are not generic. You see what I mean? And so we just need to keep in mind here that this is a particular interpretive paradigm that is supposedly a representation of network traffic, and whether we send this through DOTS is, I think, an open question. But if you're looking at something that's optional and not mandatory, okay, but let's not implement IPFix across JSON and DOTS.
Yeah. Okay. Thank you for your suggestion.
Okay. First, Andrew.
Andrew Morton, Sonoma Networks. The protocol you've described uses HTTPS and JSON, is that correct?
Yes.
Okay. You also had a slide, now I'm forgetting how many far back, but it indicated that there were server to client messages as well. Is the client to be running an HTTP server as well?
Most of the server to client messages is all the response message, but okay, we have the status message. It's from server to client.
I think there it is. Yeah. Server to client messages.
Yeah.
Okay. So does the client need to be running an HTTP server? We have mitigation status reports, and so these all need to be initiated by the client. Then is that correct?
Sorry.
All of the messages, the server to client messages, all need to be initiated by a client request.
Yes. Yes.
Okay.
Yes.
Hi, Liu Yanfang. This is more to the chairs. I think we need to have the chairs in this working group and the I2NSF kind of really define the scope, because we know what we want. And more likely, some portion is here in this group, some portion goes there. Like, how do we have not just the during attack time, regular time, right? Exchange information on capability, on, all these, everything, right? What you're capable to do, all the rate limiting, all the blacklisting, all the different things. And then there's a blacklist, whitelist, all whole lot of things, and the reporting, which part is, fitting signaling here, the scope, and which part it just to the other part. So I think that's one piece I'm not totally clear on the scope. Yeah.
So, excuse me, Tobias Gonum, co-chair. So yes, at this moment there is a certain overlap or kind of part where it might be I2NSF, it might be DOTS. If it's a principal function for I2NSF, I think my personal opinion, not speaking as chair, my personal opinion would be it would be I2NSF. If it is something that is required in the DOTS situation only, then we should do it here. That would be my personal opinion. What I can say is that the chairs are very closely talking with the I2NSF chairs. And at this moment, I feel we are more in the exploration phase. So we see what are the use cases, and where we put the solutions, it will be either here or there. Yeah. The main concern is we don't want to lose them, okay? Because if I think, oh, it's an I2NSF, but I2NSF thinks, oh, it's in DOTS, and then we do it nowhere, that would probably be the worst outcome. So, but we definitely hear you, and we have a close communication. Also, the chairs were in I2NSF and vice versa. So, yes, you're very well received.
Thank you.
Thank you.
Frank, can I ask one clarifying question? Thanks for putting the implementation information in there. So back to the use case mapping, you said interdomain, intradomain. I don't think about it that way. I think in terms of drafts. So can you talk about which use cases and what drafts you're covering with this protocol?
Yes. currently draft actually we propose a DOS protocol and its message. We want to accomplish the coordination among different operators. That's our initial goal. But when we write it all down and we think around, we think a long time. We think that of course we only need one DOS protocol. I think whether it's intra-domain or it's inter-domain. So I think that our protocol, our message can also be used for intra-domain. So you know the story is long, but
So I guess I'm just trying to understand, is your protocol, if I hear you right, is covering the use cases you have documented in the draft that also describes the protocol? Got that. Does it cover the use cases described in the working group document?
yes, I think so. I think so. It can support those use cases.
And does it cover the use cases that are in the third use case document?
Third use case, you mean that this draft?
Well, so you're describing a protocol. We have 3 use case documents. We have
we have
the
working
use
group.
case,
Yeah,
we have the working group
I
document.
hope that we can cover all the use cases.
Okay.
Yeah.
And then there's Konami's independent draft. Does
Yeah.
it cover those use cases?
Yeah,
as well?
yeah. We hope so. Yeah.
Thank you.
I'm not sure whether now is a good time to ask, but maybe it is, because the other two are maybe not so related to protocol implementations. So I really like us moving towards the protocol part. So I'm very happy about this from a chair perspective. I'm wondering whether there are current ongoing implementation works towards this. So I heard there's some code here. I also saw in the previous presentations that there's like code blocks, but it didn't seem like there's a DOTS implementation. I was wondering whether there are currently ongoing implementation works, and or if not, then I want to strongly encourage them, because I believe, I mean, running code is very important at IETF. So I think that would be useful to inform the draft work. Okay.
Hey, Nick Teague. Yes, there is various chunks of running code that's flying around. But I think it's also important to understand there's also quite a lot of existing prior art out there that does similar things, and we should enumerate that as well and list that, because that could help us help inform us how to proceed. A lot of the reason for this working group was to consolidate a lot of that work, as well as, so I don't think we should do it completely blind to what is currently out there. I think it should help inform us, as well as we should, it should be a two-way street. But yeah, there is prior art out there, but there is also kind of running code on the DOTS theme, yes.
Okay. Okay. With this, I think I hand over to Bob. Oh, one more comment. Sorry.
Yeah, one more comment.
Bob, you can
So
already-
internally, we already have the implementation of the single home and multi-home use case of my use case draft. So it's not, as for now, it's not depending on the DOTS protocol itself. It's internally using our protocols. However, we are happy to move to the DOTS protocol to implement the single home and multi-home and also delegation model of the use cases.
I appreciate that. I think one of my concerns is I don't necessarily see a mapping between the protocol here and some of the requirements we've identified.
Roland Evans, Arbor Networks. I want to indicate that I agree with the last couple of comments there, that there's not a good mapping.
Okay, Bob.
At the November, Bob Moskowitz, HGG Consulting, working with Huawei. Back in the November meeting, we had a lively discussion, you may remember, about challenges of using even UDP and why some of the providers are saying that's why we use telephone calls and text messaging. So I took this to heart and I said, okay, what are the alternatives? What else do we have if we want to not use UDP? So this is an exercise in looking at what else may be. If it does nothing more than generate a solid discussion, a way forward, it has served its purpose. So now, move forward, please. So I'm going to cover the networking issues as I understand them. Peer-to-peer versus RESTful, security context of fate sharing, then transport alternatives, and the discussion, please. So the network issues faced by DOS, we discussed this extensively. Messaging during the worst possible time. UDP filtering upstream ISPs may interfere with DOTS over UDP. Double-edged effect of lessening the impact of an attack, but interfere with UDP-based signaling. So how do we get this to work? Continue. Further, DOTS servers independently message dot clients. As we have in a couple of drafts, the attack seems over. So how does a peer provide communications with REST? Two messaging channels. We just pointed out the sending that on a server on the client, or am I going to be using unsolicited responses? And how unsolicited responses work in a restore state if either agent reboots? Now, will unsolicited responses work in a bad situation? Continue, please. Further, DOTS cannot afford computational costs of secure data objects. This is kind of like we all kind of know this, but put this in for completeness. PAM on one side, it's got plenty of time to do the data objects. DSRC, digital safety radio communications, which is vehicle to vehicle, they're throwing the hardware at it to make it like 100 milliseconds response time on signing and responding to and recognizing messages. So they're putting that in the cost of your car. We can't do any of those. Secure communication trades this cost with that of maintaining security state. So security state varying with communication state, ESP, TLS, DTLS. The greater the fate sharing, the more rigid security context, the larger the attack surface. So designing for DOTS, what should I be looking for? What did I go out looking for? Bidirectional, either agent can start, either the client or the server can start. Not commonly blocked during DDoS attacks. Minimal data over the wire to fit into a single MTU. Support peer communications, that goes back up to that first point, and secure with minimal fate sharing. That's what I went looking for. So what did I end up willowing it down to? ESP and transport mode looked doable, and GRE kept on popping up. GRE tunneling and some GRE compressed, because GRE tunneling has got a lot of overhead, but could we do some compression there? And then UDP with message level security, which again gets back to some UDP issues. Please continue. So what you see in this draft is a walk through what else we would be able to use if we assume that, no, you can't use UDP. Now, you may decide, and we discussed this on the list, that no, it's only the downlink which is congested, so we can send our UDP messages, and if the attack has been mitigated, really has been mitigated, the client will get the message, the attack is over, and be able to respond to it. So we have these discussion lists, so you may say, this was an interesting exercise, but we're comfortable with it. It may be also say, well, here's something we can keep in our back pocket when we actually get out there and start doing things. And in a meeting yesterday in I2NSF, there was a comment on one of the slides that attackers don't use standards. And I challenged that. I said, attackers love standards because then they know how to attack you by analyzing your standard. So is this then something that we'll want to investigate as an alternative backup approach when things really go down the tubes and what we're doing won't work? I leave it to the group to discuss. I found it very interesting to say about, boy, we really limited ourselves in terms of the hammers we have to work with in the IETF. But it's now up to the rest of you and what you want to do with this. I found it interesting, and the discussion I found interesting as well. So does anybody want to say anything to this at this time?
It's Dick Dolson. Thinking about, implementation, UDP has port numbers, right? GRE doesn't. So if I'm thinking about an attack, say someone's trying to attack this interface, right? I think that's kind of one thing we're worried about. It's, I think, kind of hard to filter GRE at a firewall because there's no port. And thinking about standard, it seemed like if it might be counterproductive to specify a standard UDP port because there's a port for an attacker. Whereas it may be better to say in the DOTS protocol, the port, maybe we can use multiple ports or the port numbers can be agreed between partners. So there's not like port 1, 2, 3, 4, 5 that everyone knows about. So just the port, if the port number is not well known or standard, it may be, or even if multiple ports are possible, it may be a better thing to look at.
Thank you. Excellent point.
Roland Dobbins, Over Networks. With regards to port numbers, having an assigned port is extremely vital so that operators can wrap policy, IACLs, infrastructure ACLs, and so forth to filter out DOTS traffic, from random sources on the internet. So the solution to that problem is not to try to have a dynamically negotiated port number, but rather to implement best current practices to limit DOTS communications amongst established DOTS peers. With regards to the UDP filtering situation, I think there's a bit of a misperception that has been somewhat propagated. And we've talked about this offline, but this is more for the group. There is not wholesale filtering of UDP going on in the internet. The internet would not work if that were the case. You would not be able to play Call of Duty. You would not be able to use FaceTime or Skype. What some operators have chosen to do is they are mainly looking at UDP port pairs for commonly abused UDP reflection amplification vectors, and they are choosing to sync a lot of that traffic at the edge. But there is not wholesale blockage of UDP across the internet. There is a lot of overblocking of UDP in the enterprise side of enterprise endpoint networks, which is why we need a stateful transport as well as the stateless transport. With regards to GRE or a GRE-like protocol, those things are very heavily filtered in enterprise endpoint networks. And so some of the assumptions here, I think, are a little bit, how shall I say, not necessarily reflective of operational reality in all regards.
Yeah, the point you make there about what ports are filtered and how they do the filtering, then maybe something we need to capture in the story, in the use case, as advice, again, to the operators on what they should be doing.
Absolutely. Good feedback. We will do that. Thank you, sir.
Fleming Andreessen. Yeah, I think, as you said, it's been an interesting exercise and a lot of good discussion has come out of it. And my takeaway from that discussion is that, I certainly feel more comfortable with a UDP-based solution as opposed to a GRE-based one. So I would suggest, focusing on the UDP-based one.
As I said, my goal was to get a discussion, and I believe I achieved that. If this document is not revved in from here on out, I'm not bothered by that at all.
I would, yep, thank you. Yep. Yep. I would echo that. So thank you very much. I think it was a very good and interesting exercise. Yes. So that moves, I think, to the next again. Yeah.
Yeah, next again.
So we don't let you go.
Don't let me go.
Before you start, Bob, I just want to make sure, how are we doing with the blue sheets? Has everyone signed it? Does anyone need to sign the blue sheets? There's one in back of you. It's coming up. Thank you.
Okay. So work that Sue Harris and I have been doing in defining a secure session layer services. This is we're looking at this in a number of cases. I2RS is example of them, some in I2NSF. I bring it here because I feel that it addresses some of the requirements that we have in the DOS requirements, and it's a valuable addition to what we've been doing. So first slide, please. So what is secure session layer services? It introduces an OSI style session service independent of underlying transport services, offers a set of services to an application, And a peer KMP is used to negotiate these services. IKE or HIP are examples of peer KMPs that we have here in the IETF. So that is the model that we have. Going on to the next slide. So why SSLS? Different circumstances may benefit from differing transport for DOTS messages, TCP, UDP, even potentially SMS. Fake sharing between security and transport offers a cheap attack surface. What can I do as an attacker? Years ago, I read a book where the attacker is named Malice. So I'm Mal, and what am I going to do to this thing? I'm going to knock over your ability to communicate. How am I going to knock over your DOTS server? So that's what I look at. Because I have fake sharing, how can I make this not effective? A peer KMP makes recovery clear when either agent can restart security contexts. So both IKE and HIP have very good restart mechanisms from either side, and to get that security context up and going. SSLS has a number of services and mentioned on the list. Not all of them reply to DOTS. Definitely, because of small message size, what do we need chunking for? Because the messages are not indeterministic like you have in NetConf, which potentially has large messages, and it's like, when do I know the message is done? In fact, NetConf has within it a chunking portion. Compression, again, DOTS message is already small, and the compression will probably come back and say, I have nothing to compress, so don't even bother with that. Fragmentation reassembly, not for UDP, the message is small enough, but if your devices are able to message over SMS with only 140 characters, you may say, gee, for that transport, I need a fragmentation and reassembly mechanism. And yes, I can even use that to get my messaging through when everything else has gone down the tubes. Continue, please. So what is SLS providing? Principally, the secure session envelope, SSE. It's basically ESP moved above transport, smaller header compared to ESP. KMP is like V2 or HIP V2 or DEX. I don't think we need the really lightweight of DEX here. Pure KMP allows either agent to restart. Security session can even survive reboot if stored properly. So if you are storing your security station in a secure store in a TPM or something like similar to that, the box gets knocked over, comes back up, you have all your security state. You don't care the fact it's a different TCP port or anything else, UDP, your security is going in. So attacking the box, knocking it over is no longer a worthwhile attack. So that's not the thing the attackers be looking for to do. So go ahead, please. But SSLS is new. It can use IKE V2, as I pointed out, over UDP for NAT traversal. And I should point out that Charlie Kivinan has made changes to IKE V2 and IKE minimal that for work the two of us have done over IEEE 802.15. To make it more independent and not fake sharing itself. So those changes apply here as well. There is, I say net, it's actually FreeBSD API example available. And I don't know if Sue Harris is here for her talk, but she is working on toward a hackathon in July to have code for I2RS. Operational benefits make it operational benefits make it worth the development. That yes, this is something new, but if you look at, we're talking about the bidirectionality and how will the bidirectionality with co-op, with any other method survive a breakage of the state, and how can we make it more survivable? So that was my goal here, was to increase the survivability of the DOTS communication channel. Next, please. So that's my presentation, and I welcome discussion and see where we may go with this. Roland, thank you.
Roland Dobbins, Arbor Networks. Something that you mentioned here, it's actually kind of a corner case, but I think it's actually really important that we do keep in mind having an ultimate fallback position of an alternate out-of-band transport entirely. So, SMS, what have you. And the thing for folks to think about here as well is that there may be some default messages that folks may want to generate, and just like you can with a lot of the two-factor authentication applications, you can get auth codes that you generate and write down ahead of time, so that if you can't use your 2FA system online, that you can still authenticate. And so this is a corner case, but it's an important one. We've run into this kind of thing before operationally, so it's not just a theoretical sort of thing. So alternative transport is a consideration we should keep in mind.
So I welcome interested people to work with me on this as an add-on to DTLS, as most are proposing, as another way to provide the security context for the DOTS messaging. It is not meant as necessary as 100% replacement or to start out, but I said I'm working on this in as many venues as I can, because I think it addresses a real problem that we have, as Roland just alludes to.
Yeah. So Tobias, working group chair, hat off. I apologize to you, Bob. This is actually a question following to Roland. So if we need this alternative messaging channel, is this outlined in the use cases? Because maybe I missed that. If we need the alternative, like SMS channel, is this outlined in the use case as a or in the requirements?
It has not been, but it should be. So your point is well taken.
Okay, thank you.
Yeah, it's kind of vague in the requirements right now. Maybe need to firm that up for that particular point to be there. And what you have when you do this, you can now have any one of a number of different mechanisms underneath you making that transport decision. Happy eyeballs or any other, or watching your interfaces, see which interfaces are working to make that decision that right now I'm going to use this transfer. Right now I'm going to use this interface, and it's the one security context which is used for whichever communication path you take.
Roland Dobbins, Arbor Networks. Tobias, additionally, in the 0-1 use cases, there's one that involves a web browser. There's one that involves a handset running a DOTS client. Those are out of band in the context of that particular attack, right? So they are out of band, but they're not out of band of TCP/IP. So.
Good, thanks, Bob.
Thank you very much.
So that brings us to the end of our time. We actually fit in everything on the agenda, so I really thank the presenters and kind of those bringing up discussion points. Let's take the rest of the conversation to the mailing list. A lot of places where we still need to chat. The working group is still looking. If you have ideas on protocols, please continue to bring them to the working group. Otherwise, safe travels, and looking forward to seeing everyone in Berlin. Yeah. Take care.
Thank you.
Can I have the blue sheets, whoever's holding the last clipboard? If you haven't signed it, please come on up and get on the list. Thank you. Thank you. Does anyone get the blue sheet? Yeah.